So in this video, we're going to talk about numbers 16 through 20. Number 16 says silver nitrate. Silver, we know it's Ag. And nitrate is one of those common polyatomic anions you should know. Nitrate, if you find it, it's right there, NO3 minus. NO3 minus with a -1 charge. Okay, so that goes NO3 with -1 charge. We know that silver itself is +1 charge, so nitrate is -1, so we don't have to, that's already balanced in charge wise. And then plus zinc chloride. So zinc is Zn. Zinc, you should know that has a +2 charge. And then chloride is chlorine, and when it's ion form, that's Cl with 1- charge. Okay, so we need 2 of those. Now they're gonna react together. Looks like this cation will replace that. Okay, so Ag will bind with Cl now, like that, because Ag is +1, Cl is each Cl is -1, so they're already balanced. And then we got zinc, the other cation, binding with nitrate right there, so NO3. But then we know zinc is 2+, so we need 2 of those, 2 of the nitrates, like that. Okay, but we're not done yet. We need to balance. So Ag, we got 1 each. But then when you look at nitrate as one thing, you only have 1 nitrate right there, but you got 2 of them. So I'm going to put 2 in front of AgNO3, silver nitrate. That will make two silver atoms here. So we need to put 2 over here, and that should do it. Okay, so that's how you do number 16. Let's look at number 17. We got copper, that's Cu. Hydroxide is OH. Okay, that's another anion that you should know, OH with -1 charge. All those polyatomic ions, if you haven't memorized yet, I mean, for honors class, it's okay. I think the teacher's going to give you all these charts, okay, with all those polyatomic ions. And then you could just refer to this, okay? So I'm going to hide this. No, I'm just going to use this right now. Cu with hydroxide is OH, so H, but then we need 2 of them because Roman numeral says it's got 2+ charge. And then acetic acid, well, there's 2 ways of writing acetic acid. The one on top, the one on the bottom. They're the same thing. Okay. So I'm going to write acetic acid. That's acetate, so you need 1 more H. So I'm just going to put H right there. I put only 1 H because acetate has -1 charge. So I'm just going to put CH3, COO like that with no charge. That's acetic acid. Now that's going to turn into, now that cation, that H will be protonated and bind with OH to become water. Okay, and then that leaves us with copper binding with acetate right there. So I'll put Cu and then acetate. Hold on, let me hide this for now. So it's CH3 COO, but that's got -1 charge. This whole thing has -1 charge, but then copper has +2 charge, so you need to put parentheses here and just put 2. Okay, and that leaves us with this hydrogen right there, because it's going to get protonated because it's acid, will bind with that hydroxide, the whole thing OH, to become water. Okay, I'm just going to put plus H2O right there. Now we need to balance it. When you look at this, we just when you look at this acetate here, we only have 1, but then you had 2 on the right side. So I'm just gonna put 2 right there. Makes it 2 acetate right there. But that just made 2 H's. Well, it's got 2 of those OH's, so we need, that makes 2 water molecules right there. So it's 1:1:2 ratio. Oh, I forgot to mention, number 16 is double replacement reaction, okay, because we got partner swap happening. Ag replaces zinc, and zinc replaces silver, so that's double replacement. What about this one? This is also double replacement right there. Let's look at 18. All right, so you got 16 and 17. I'm gonna, what is it? I'm gonna bring it up a little bit. So let's look at 18 now. 18, it says iron sulfate iron is Fe with a 2 plus. And then sulfate, when you look at this polyatomic ion again, it's going to be right there, SO4 with 2 minus. So that's going to be SO4. Since iron is 2 plus, which you could just leave it like that. Okay, let me just write it a little bit closer right there. Okay. Now that's going to react with ammonium sulfide. Ammonium again is one of those polyatomic ion. So it's NH4, but it's got what? It's got +1 charge. But sulfide is right there. When sulfur turns into, when that sulfur turns into ion, it's going to be sulfide. Well, all these columns will have 2 minus charge, okay, when it gains 2 more electron. So ammonium is +1, like we said. So we need 2 of those, and 1 of the sulfide right there. Okay, that's how you do it. That's gonna react. Those two gonna react and form that cation will bind with that anion right there. So Fe will bind with S. Okay, and we do. Let's see. Fe was 2 plus. Sulfide was 2 minus. So they charge-wise they cancel each other out, and then we got NH4. That's 1 plus binding with SO4. That used to be 2 minus. So you need 2 of these. Okay, so that's how you balance it. This is also double replacement. So let's look at number 19. Barium. You look at periodic table here. Barium is where? Oh, it should be over here. You can't really see it, but it's on second column right there. So Ba has 2 plus charge. That has 2 plus 2 charge. Chloride right there is -1 charge. So you need 2 Cl's right there. Okay. And then reacting with sodium right there with 1 plus 1 charge. But sulfate, again, you need that. So sulfate is right there, 2 minus charge, SO4. So you put SO4, since this is 2 minus charge, you need 2 of the NAs. So you have to put subscript 2 right there. Okay. That's going to react. Let me hide these now. So those two gonna react. You guys predict what's gonna happen here. Na, that cation will bind with Cl. So you got NaCl here. And then that barium, which is 2 plus, will bind with that sulfate. Since this is 2 plus, 2 minus, you don't need to do anything right there. Now what just happened? Well, you had 2 NAs here, but you only have 1, so let's just put 2 there. And that will solve it, which will make 2 Cl's. You got 2 Cl's right there. So that's again double replacement right there, double replacement. So number 20 now. Calcium. When it says just calcium, that's just metal calcium right there. You don't need to do anything. Hydrochloric acid name, just know that it's HCl. Okay, it's a strong acid. Okay. Now, when you put a metal with hydrochloric acid, some bubbling will happen. That bubbling is usually the hydrogen gas right there. So Ca will kick out H and bind with Cl, but calcium, since it's in second row, right there, second row, it has +2 charge when it becomes ion. And then Cl is -1 charge. So what's going to happen is that Ca, when you need 2 Cl's, okay, and then that H is one of those diatomic molecules, so it's always exists in H2. So that's what's gonna bubble in. All right, so let's balance it now. So we got 2 H's here, and then 2 Cl's on the right side. Just put 2 here. Okay, this is Ca replacing H. So this is considered as single replacement reaction. Okay, so for other ones, look at this video right now.